So we're learning this week the basics of a fundamental set of ideas that occur throughout the sciences, including environmental science and ecology, and that is thermodynamics. And we tend to think of this in environmental science as energy. Although thermodynamics really concerns itself mostly with heat energy, but this really is true on some level or another with all forms of energy. And so this will always work out whether we're talking about energy flow in a biological system, energy in a factory or solar technologies or whatever. We may have to do a little tinkering with whether we call the energy watts or joules or horsepower, but this will always be true here. So we start off with two laws of thermodynamics that are universal. That means it applies across all physical systems, and it applies, we presume, throughout the universe. The first law of thermodynamics tells us that energy is neither created nor destroyed, nor is it is only transferred. And the second law of thermodynamics, even though that energy does not get destroyed on a universal level, it will be lost to whatever system it was in once it is being used, once it's being converted, and generally it will be lost by heat in some way or another. So unless we have an outside source of energy, material or a material system, whether it's an engine or it's an animal or whatever it is, we're always going to be seeing a gradual loss of available energy. And thus, the very nature of that energy that we're looking at will decline in quality too as it becomes dispersed, outside of the system or into the universe at large. So high quality matter and high quality energy will always degrade spontaneously to lower quality. We're not going to see the reverse unless outside energy has been supplied. Let's take a look at photosynthesis and respiration to speak of a series of biochemical relationships in nature that starts ultimately with the sun as an outside energy supply. So as we've learned in biology class, plants are producers, and they draw in carbon dioxide and water, which would be considered relatively low quality matter or low quality energy sources, and it combines them into a higher quality source. They get reduced down to some sort of carbohydrate like glucose or sugars, fats, starches, what have you. And then when we burn off the food that we've consumed as consumers, that energy has degraded as the quality of the material is degraded back down from our carbohydrates back to carbon dioxide and water, which we respirate off. And so were there not a constant resupply of energy from the sun, then we could not reverse the process of high quality energy degrading into low. So let's also look at an example of using energy to improve materials, at least from the standpoint of human use. So right here I have a big hunk of iron ore known as hematite. And this was drawn from one of the West Tennessee counties where iron ore is in fairly high quality. This could be anywhere from 30 to 40% pure iron. However, it's locked into a lower quality form of iron oxides, and we call these minerals hematite. So it's not usable as the iron that we normally think of for refining into steel and other metal products. So this is relative to the metals that we think of that are iron-based. This is low quality material, okay? And so this is iron in its oxidized form. It's a lower quality form. But we can reduce it down and increase its purity into a hunk of iron, such as this little cannonball or whatever that may or may not have come from the Battle of Lookout Mountain, which is a pure iron, though there's a little rust on top of it, or even a higher quality form, really high purity form, such as this piece of steel of this U-boat here. But the journey from this hunk of rock to this piece of stainless steel requires a tremendous burst of heat energy, amongst other things. And historically, humanity has used coal as disposal. This piece of coal came from Signal Mountain. One of the reasons Chattanooga historically was a big steel manufacturing town was because we had local supplies of coal and regional supplies of iron ore. So that we could use this coal as an energy source to transfer low quality material into higher quality. As we know, left to its own devices in nature, this will eventually rust down back into oxides, back into what we call rust, and it becomes lower quality all over again, unless we want to gather it up and resupply it with energy to free up the pure iron. So, that is thus a quick look at how the laws of thermodynamics tell us that both mass and energy will degrade in quality as energy is transferred unless there's an outside source of energy that is put to use to up the quality of that material or that energy again.